Question 40, we've got our ladders question here. We've got this ladder here. It's a uniform ladder from A to B, and it's got mass M. So we've got a force here of mg pulling it down, and the distance there to there is 1 meter. There to there is 1 meter. What else have we got? We've got that this is 60 degrees here. We'll need that in a minute. We're going to have a normal reaction on the ground here, and we're going to have some friction on the ground stopping it sliding back there. At this end here, we've also got a reaction from the wall pushing out here. I call them S. I haven't got any friction here because it says it's a smooth wall. We've got more to put on. We've got to put the man on as well. The man is weight 3m. So let's put him here. I've got 3 mg coming down here. And he's saying the distance to the man there is 0.5 meters. So I've got that there. Mine always look a bit of a mess there. I'm sorry about that. Now, in all ladders questions, we're going to go up and down, left and right, and we're going to take moments. So let's do the easy one first. Let's do left equals right. Because the only force going to the right is the friction, and the only force going to the left is the friction against the wall, and that's going to equal 0. And so I've got that S is equal to the friction. We'll park that there for a minute, and we'll come back to it. Oh, actually, no, we can go again. That the friction is equal to mu r as well, isn't it? So we can put that in there. And it is actually mu. We're going to be trying to find out later, isn't it? Let's go forces down as well then. So the forces down, I've got the 3 mg, and we've got the mg minus the r, and that will equal 0. So here I've got the r is equal to 4 mg. And let's put that in there. And so S is equal to 4 mg mu. And we'll need that later, so we'll stop there. Right, here's the big bit. Moments about the ground, moments about A. And we've got 3 of them to do. We'll take each of them in turn. Every time we go force, distance, bit of trig. So the man, first of all. The force of the man is 3 mg. The distance, well, it could be the 0.5 here, but it's not, because you want perpendicular distance. So the perpendicular distance to this force that goes down here is the distance there to there. That's next to the angle. So I've got a cos 60 coming in here. Let's repeat it for the next one. The next one, we've got the force here of mg. The distance there to there is 1. And look, the force here is going down like that. The perpendicular distance is this bit here, and this is next to the angle, so it's a cos of 60. The force stopping it turning is the S force. No, that's that one there, 4 mg mu. Let's squeeze that in there. The distance there to there was 2. And this force goes like that. The perpendicular distance is there to there, which is the same as there to there, which is the sine of 60. And we fitted it all in, and that equals 0. Right, just got to do some tidying up then. What can we do? We can cancel the m's. All these m's can go. We can cancel the g's. All these g's can go. I can write it out nicely now then. So I've got 3 over 2 cos 60 plus, there's another cos 60 there, isn't there? Equals, let's add that to the other side. I've got 8 sine 60 times by the mu that I'm trying to find. And so what's mu going to be? Add those two together. So I've got 5 over 2 cos 60 divided by 8 sine 60. Let's tap that in. So putting that all in, I'm getting 0.18 as my mu. So look, you've seen me do this before. I leave all my cos 60s and sine 60s right to the end. Yeah, we can tap those in, and we know cos 60s are half anyway, don't we? But we could do them earlier, but I prefer to do it all at the end because that helps me when I have to rearrange these to maybe find out what the angle is in a different question.